In this video, we'll learn how to find the domain of this given rational function. First, let's review the definition of the domain of a real-valued function. The domain of a real-valued function f is the set of all real number inputs x for which the corresponding output f of x is also a real number. Applying this definition to the given function, we see that a real number x should be included in the domain of f if f of that real number, or in other words, this expression evaluated at that real number, is defined. Since division by 0 is undefined, the real numbers for which this denominator expression is 0 should be excluded from the domain. So we may summarize this discussion as follows. By definition, the domain of the given function is the set of all real numbers x except the ones for which x squared plus 5x plus 6 equals 0. We now solve the equation x squared plus 5x plus 6 equals 0 to find the values that are excluded from the domain of the function. Pause the video and solve this equation. Factoring the left-hand expression, we get this line. Remember, x is a real number, and so these two factors are also real numbers. This line says that the product of two numbers is 0. The only way that can happen is if at least one of the two numbers is 0. Thus, we get this line. Solving each linear equation, we get this. Thus, the solutions to x squared plus 5x plus 6 equals 0 are -3 and -2. These are the numbers that make the denominator 0 and hence are not in the domain of the function. Every real number except these two can be put in as an input into the function to get a real number output. So we can write the domain in set notation, the set of all x such that x is not equal to -3 and x is not equal to -2. On the number line, the domain is seen to be all points except the two we just mentioned. If you choose to write the domain in interval notation, then we can proceed as follows. The leftmost interval can be written as this, and then we write U for union of two sets. The middle interval is this, and once again we write U for union. And finally, the rightmost interval can be written like this. Now, even though we worked with a specific rational function in this example, the general strategy we used here can be applied to find the domain of any rational function. Rational functions have this general form where the numerator and denominator expressions are polynomials. A good way to start when asked to find the domain of a rational function is with this opening sentence. Next, solve this equation. In an actual question, you will be given a polynomial expression for q of x, most likely linear or a quadratic expression for this class. That's it for today. See you in another video. Thank you.